Good evening, children. எப்படி இருக்கீங்க? நல்லா இருக்கீங்களா? And நம்ம last classல என்ன பார்த்தோம்? The relation between the partial pressure and the mole fraction. என்ன எடுத்திருக்கோம்? நம்ம solutions எடுத்திருக்கோம். A mixture of two liquids. A solution of mixture of two liquids. We'll also see, I told you it will obey Raoult's law when what we have done last class, we said about Raoult's law. Raoult's law anna, the pressure is equal to the pressure of liquid in a mixture is equal to the product of its mole fraction into its vapor pressure. So for an ideal solution, if two solutions mix panna ideal solution vaangum. Eppa avum ideal solution if the total pressure is equal to sum of their vapor pressures, or let me say the vapor pressures in the solution state. So we'll just see the continuation of it. Enna Aditi varliya inno? Vaita irukka? Good evening, Aditi. Are you there? Good evening, Maithili. Okay, let's start with our next topic, or let's see the continuation. Understanding of solution concentration terms paathirukom, Henry's law paathirukom. Henry's law, Henry's constant. What did we do in Henry's constant? More the Henry's constant, lesser is the solubility. More the Henry's constant, lesser is the solubility. And Henry's constant, universal constant madri light will be different for different gases. And more the temperature, more will be the Henry's constant. And more the Henry's constant, lesser only solubility vandu romba kammiya irukum. So liquid solution, Raoult's law we'll just see little more. Okay, fine. Let's go with liquid solution. So enna agum liquid edavadhu solution edtha some of the liquids molecules will go up. Idu vandu liquid state, idu vandu vapor state. Liquid state la, like you have two different solute and solvent. It's okay, Aditi. I thought you were there. Nee irken nancha. Fine, I just started, don't worry. B vandu solute, A vandu solvent எடுத்துருக்காங்க. So it's a solution of, so you can see dots vandu solvent ஜாஸ்தியா இருக்கு, solute vandu கம்மியா இருக்கு. So solute and solvent vapor state லையும் இருக்கும், liquid state லையும் இருக்கும். If we take mole fraction of solute as, okay, solvent as A, mole fraction of solute as B, we know that mole fraction of A and B will always be equal to 1. So if it obeys Raoult's law, what did we say? Total pressure is equal to the pressure of A plus the pressure of B in solution. Pressure of A eppadi eduthirukom? Pressure of A vandu mole fraction of A into the vapor pressure of it in the pure state. P naught was the pure state, PA on the solution. PB, how do we write PB? PB on the mole fraction of B into the vapor pressure of B in the pure state. So if this is equal, then we say it obeys Raoult's law and it's an ideal solution. Ideal solution vandu any solution which obeys Raoult's law at all conditions. So how can we write this again? P total vandu XA into PA naught plus XB into PB naught. All this we have seen it in the last class. Fine, ma. Mole fraction of any two components in solution will always be equal to 1. So I can write this in terms of A instead of B. இது நம்ம A B வந்து A போட்டு எழுதலாமா XA into PA naught plus instead of XB mole fraction of B I can write it in terms of A. A போட்டு எப்படி எழுதலாம் 1 minus mole fraction of A will be mole fraction of B into PB naught. So we can either write it in this term or in this term. What are XA and XB? XA and XB வந்து mole fraction of A. எந்த ஸ்டேட்ல liquid stateல mole fraction of A in liquid state. Vapor stateலயும் இருக்கும் vapor stateல different alphabet எடுக்கலாம். Let's see what we can take in the vapor state also. இதெல்லாம் நம்ம last classல பார்த்தோமா. So vapor stateல என்ன எடுத்திருக்காங்க YA and YB வந்து mole fraction of A and B in vapor state. XA and XB are the mole fraction of A and B in the liquid state. So இந்த difference தெரியறதில்லமா. Liquid இருக்கும்போது liquid வந்து கொஞ்சம் vapor ஆகும். It changes to a gas. So இங்க நம்மளுக்கு A இருக்கும் B இருக்கும். So mole fraction of A and B in vapor state வந்து நம்ம textbooksல alphabet Y இருக்கு. XA and XB வந்து mole fraction of A and B in the liquid state. Partial pressure of liquid same நம்ம ஏதாவது gaseous stateல எடுத்துக்கோமா இந்தோ we are taking of in the gaseous state. Liquid in vapor state வந்து how do we write? The same thing which we did in states of matter. Partial pressure is equal to mole fraction into P total. What are we writing here? We are writing in terms of the same liquids in the vapor state. So vapor pressure of A will be equal to mole fraction of A in the state vapor state into P total. B எப்படி எழுதலாம்? The vapor pressure of B or the partial pressure of B எங்க இது? What A and B we wrote it previously was in liquid state. இப்போ இங்க என்ன எழுதலாம்? We are writing it in vapor state. The pressure of A and B in the vapor phase will be equal to YB into P total. So நம்ம liquid stateல mole fraction A it's the liquid state, same A in the vapor stateல YA ன்னு எடுத்திருக்கோம். So if I take PA in the liquid state, vapor pressure of A, taking up the mole fraction in the liquid state, we write it as XA into PA naught. Same number vapor state YA into P total. The difference தெரியுதா உங்களுக்கு? இது mole fraction of A in liquid state, mole fraction of A in liquid state. இது mole fraction of A in the vapor state. கொஞ்சம் difference. See, if it is more volatile in the liquid state and vapor state easier then you will have more mole fraction in the vapor state. Got this right? Next slide, Polama. Okay, the vapor pressure of pure liquids A and B. Pure liquids A and B na PA naught is equal to 450 millimeters of mercury and PB naught வந்து நம்மளுக்கு எவ்வளவு வந்திருக்கு 700 millimeters of mercury. Find out the composition of the liquid mixture. Liquid mixture எப்படி எழுதணும்? P total is equal to XA into PA naught plus XB into PP naught. XB வந்து 1 minus XA ன்னு எழுதலாம். Instead of writing it as XB, ஏன்னா நமக்கு Aயும் தெரியாது Bயும் தெரியாது. ரெண்டும் தெரியாம அந்த quantities இருந்தா we will write it in one type of quantity. XA into PA naught plus 1 minus XA. Ma இப்படி எழுதலாமா? Can we write like this? We can write it, right? P total எவ்வளவு கொடுத்திருக்காங்க? 600. So இது வந்து 600 XA. நம்ம last time பண்ணிருக்கோமா இந்த question? பண்ணிருக்கோம்ல பாருங்க. Look at the calculation. 1 minus XA into 700. So 450 into XA is plus 700 minus 700 XA. 700 in the side pona minus 700 plus 600 is equal to 450 XA minus 700 XA. எவ்வளவு வருமா பாருங்க, calculation பண்ணி பாருங்க. minus 100 is equal to 700 minus 450 எவ்வளவு வரும்? 250 minus 250 XA. minus minus cancel பண்ணலாமா? XA வந்து you will bring this 250 this side, 100 by 250. Ten by 25 இல்லைன்னா 1 by 2.5. One divided by 2.5 எவ்வளவு வரும்? 0.4. If this is 0.4, what will be XB? Maithili and Aditi, XA வந்து 0.4 வந்தா XB எவ்வளவு வருமா? சொல்லுங்க. XA வந்து 0.4, XB வந்து XB என்னென்ன? mole fraction of B வந்து எவ்வளவு இருக்கும்? A வந்து 0.4. okay, A வந்து 0.4, B good. B எவ்வளவு வருமா? எப்படி பண்ணணும்? XA plus XB வந்து 1 minus X. okay, great. பார்க்கலாமா இங்க எவ்வளவு கொடுத்திருக்காங்க? instead of 0.4 and 0.6, they have given it in terms of 2 by 5 0.4 வருமா? 2 by 5 and 3 by 5 ன்னு கொடுத்திருக்காங்க. So நம்ம options பார்த்து in case if it is given in terms of 0.4, 0.6 we'll go with that. இல்லைன்னா options நம்மளுக்கு 2 by 5 இல்லைன்னா 3 by 5 இருந்தாலும் அப்படியே எழுதணும். Okay, the problem is clear, right? புரிஞ்சுதில்லையா ப்ராப்ளம் ஈஸியா இருக்கு. There's nothing hard in it. Fine. How do we relate Raoult's law and Henry's law? Raoult's law எது பத்தி இருக்கு நம்மளுக்கு? Raoult's law is for two liquid mixtures. Henry's law எந்த solution எடுக்கணும்? It depends. See, Aditi, the answer has to be only in fractions. ஏன்னா mole fraction of A and B together should only be 1. So obviously your XA and XB will be very less. So it has to be only in fractions. 0.4, how can we write? It will be 2 by 5. 0.4 is nothing but 2 by 5. 0.6 is nothing but 3 by 5. Your total should be equal to 1. So mole fraction of A and B evlo irukku? It will be less than 1. So obviously mole fraction number liquid state la eduthalum vapor state la eduthalum it should be less than 1. You will not get a higher value. I think, is it fine? So Henry's law we will talk about a gas in a liquid. Enna sonnam Henry's law patti? The pressure of the gas above the liquid is directly proportional to the mole fraction of the gas. And we have taken the Henry's constant Kh. The same thing Raoult's law is sollam. The partial vapor pressure of a liquid in the mixture is directly proportional to the mole fraction of it. Idu Henry's law. Raoult's law enna solram? The partial vapor pressure is directly proportional to the mole fraction. P1 x1 into P1 naught. Raoult's law we are taking a vapor pressure of pure solvent. Henry's law we are taking up Henry's constant Kh. Adu mattum the difference irukkum namalku. According to Raoult's law, the vapor pressure of a volatile component in a given solution is given by P1 is equal to mole fraction of 1 into its vapor pressure in the pure state. In the solution of a gas in a liquid, one of the component is so volatile in the easier it goes to the vapor that it exists as a gas, and we have seen the solubility is given by Henry's law. Henry's law la ஒரு problem பண்ணிருக்கோம் last classல கொஞ்சம் I'll just repeat that because calculation la நம்ம conversions we didn't take it properly. The Henry's constant for carbon dioxide is given as 1.67 into 10 power 7 pascals. The vapor pressure of carbon dioxide is found to be 2.5 atmosphere. Calculate the mole fraction of carbon dioxide. கேட்டிருக்காங்க நம்ம questionல இல்லையா? இது 2.5 atmosphere கொடுத்திருக்காங்க, இது pascalல கொடுத்திருக்காங்க. ஏதாவது ஒன்னு convert பண்ணணும். 1 atmosphere is equal to 1.03125 into 10 power 5 pascals. So now we give 1.013, sorry. If we convert பண்றது difficult ஆனா we will take approximately 1. 1.01325 into 10 power 5 approximate 10 power 5 pascals எடுக்கலாம். So 2.5 atmospheres எவ்வளவு இருக்கும்? 2.5 into 10 power 5 pascals இருக்கும். So what is mole fraction? Mole fraction what is mole fraction? X is equal to P by KH தானே இந்த formula இருக்கு. P எவ்வளோ கொடுத்துருக்காங்க 2.5. let me take some other color first, erase all the rest. (2.5 into 10 power 5) pascals. இதுவும் pascalsல இருக்கு. எவ்வளோ இருக்கு 1.67 into 10 power 7. எவ்வளோ வரும் 10 power 7 மேலே போன எவ்வளோ ஆகும் -7. so 2.5 into 10 power 5 into 10 power -7 by 1.67 plus 5 minus 7 எவ்வளோ ஆகும் -2. 10 power -2. 2.5 by 1.67 1.497 1.497 approximate நம்ம எவ்வளோ எடுக்கலாம் 1.5 into 10 power -2. units ஒண்ணுமே இருக்காது எதனால because it's a ratio. mole fraction will not have any units. and அதுவும் we can also prove here. this we have taken in pascals, this we have taken in pascals. ரெண்டுமே cancel ஆயிட்டு நம்மளுக்கு எவ்வளவு வருது 1.5 into 10 power -2. புரிஞ்சுதாம்மா இந்த problem? this is not in this PPT, last class PPT 1.497 monthly. very good. we are taking it approximately 1.5. நம்ம last classல conversions தப்பு பண்ணிருக்கோம் and the power was also given little different in the calculation that is there. so I thought it's better be repeated. I think fine. we'll go on. Fine, let's go with the next one. Okay, the solutions which obey Raoult's law over a wide concentration ranges and temperature என்ன சொல்வோம் ideal solutions ன்னு சொல்வோம். when will it be ideal solution? when PT is equal to PA plus PB, or I can write again in terms of PA naught into XA plus PB naught into XP. so if this formula is followed, in the formula follow panna, that is nothing but PA is directly proportional to XA. Raoult's law enna solluma, the vapor pressure of a liquid in a liquid mixture is directly proportional to the mole fraction. or we will write PA is equal to XA into PA naught. this is in the pure state. so this is Raoult's law. if any liquid mixture obeys Raoult's law over a wide range, ரொம்ப long range concentrations இல்லைன்னா temperature changesலும் அது follow பண்ணா we'll call that solution as ideal solution. நமக்கு ரியலா எப்பவுமே ideal solution இருக்காது, but we can make some closer to ideal solution. non-ideal solution வந்து which will not accept or which will not follow the Raoult's law at all concentration. it can be one with a positive deviation, it can also be with a negative deviation. so even this formula we have seen it last time. I also told you between two liquids the force of attraction between the similar molecules we call it as AA forces. between the other liquid that is taken as BB, the forces between the molecules enna solvom cohesive forces nu solvom. we call it as cohesive forces. cohesive forces are forces between similar molecules. and the forces between different molecules from the adhesive forces. நம்ம ஏதாவது stick பண்ணனும்னா என்ன பண்ணுவோம் adhesive material gum எடுத்து we will apply the gum and then paste it. So paste பண்ணும்போது என்ன ஆகுது, it is attaching, two things are getting attached. So அது வந்து adhesion ன்னு சொல்லுவோம். So the forces between two different molecules வந்து adhesive forces. So in ideal solution, the AA forces, the forces between the molecules will be same to that of the forces between different molecules. Such a molecule, such type of liquids, we call it as ideal solution. So solutions in which solute and solvent interactions are almost similar to that of solvent-solute forces are called as ideal solution. நமக்கு perfect ideal solution இருக்காது. We can make some which are closer to ideal solutions. Example வந்து benzene, toluene, carbon tetrachloride, silicon tetrachloride. Homologous series எடுக்கலாம். Homologous series என்ன? The immediate member which differs by one CH2 group. N-hexane, N-heptane on the homologous series. C2H5Br, C2H5Cl. Those which have more closer, what to say, properties. PHCl and chlorobenzene, bromobenzene, illana phenyl chloride, phenyl bromide. Remember the examples. இதெல்லாமே நம்மளுக்கு ideal solution. Graph last time பார்த்திருக்கோம்ல. If it is an ideal solution, it will obey this. And why one is drawn here and one is drawn here? It's only to show ரெண்டு difference இருக்கு. Vapor pressure, both will not have same vapor pressure. To show the difference. ரெண்டுக்குமே difference காட்டுறதுக்காக இங்க ஒரு one we are taking it as low, the other one we are taking it as high. So next slide போலாமா? So if it is an ideal solution, என்ன ஆகும்? The delta V mixture வந்து 0. Delta V mixture 0 ன்னு என்னங்கம்மா? நமக்கு volume வந்து if we mix up two liquids, நம்மளுக்கு generally என்ன ஆகும்? If I take 20 ml of one liquid, 20 ml of another liquid, if the forces are equal, it will become 40 ml. If the forces are not equal, it might be more than 20 plus 20. If the forces are not, if the forces are, let me say the forces are more, the volume will become less. ரொம்ப closer on the molecules. If the forces of attraction are less, molecules will go away from each other. அப்ப என்ன ஆகும்? நமக்கு volume increase ஆகும். So if the force of attraction between AB is same as AA or BB, volume வந்து நமக்கு equal இருக்கும். So the delta V mixture வந்து 0 ஆகும். Heat is neither absorbed nor given out. So enthalpy of mixture வந்து 0 இருக்கும். Absorbed vapor pressure and calculated vapor pressure வந்து same இருக்கும். What is delta S mixture? Entropy of mixture is greater than 0. Entropy of mixture greater than 0 is a positive value. If it is a positive value, we call it spontaneous process. அப்படியே delta G, Gibbs free energy வந்து negative value இருந்தா, it's a spontaneous process. இதெல்லாமே you will have to remember. Simple. If a liquid obeys Raoult's law, there will be no volume change. A heat is neither absorbed nor given out. Exothermica irukadu, endothermica irukadu. Entropy வந்து positive இருக்கும், Gibbs free energy negative. Absorbed vapor pressure, boiling point calculate பண்ணதும் நம்ம observe பண்ணதும் same இருக்கும். Clear, right? We'll go to the next non-ideal solutions. Non-ideal solutionல என்ன ஆகும்? P total வந்து ஜாஸ்தியாவது இருக்கலாம் இல்ல கம்மியாவது இருக்கலாம். That is, P total can either be more or less than PA plus PB. So non-ideal solution showing positive deviation. Positive deviation எப்படி இருக்கும்? எப்போது நமக்கு attraction between AABB molecule is much more than AB. It doesn't prefer to interact. They don't remain close. அப்போ எப்போவும் they go away from each other. And the observed vapor pressure of each component and the total pressure are greater. இது இருக்கும். If it is a positive deviation. புரிஞ்சுதாம்மா? If it is a positive deviation, the sum P total வந்து ஜாஸ்தியா இருக்கும். இது ஜாஸ்தியா இருந்தா என்ன ஆகும்? Delta V mixture வந்து will be more a positive value, higher value. Delta H mixtureம் ஜாஸ்தியா இருக்கும். இன்னும் என்ன சொல்லலாம்? What are the examples? Ethanol, water. Between ethanol molecules, the hydrogen bonding is stronger. Between water molecules also, the hydrogen bonding is stronger. So, அப்ப இது ரெண்டுமே combine ஆன. I mean, if you find the intermolecular force of attraction between ethanol and water, அது கம்மியா இருக்கும். Between ethanol molecules, you find hydrogen bonding, right? Hydrogen bonding இருக்கும். இந்த hydrogen bonding வந்துக்கு நம்மளுக்கு கொஞ்சம் ஸ்ட்ராங்கா இருக்கும் when compared to the hydrogen bonding between water and ethyl alcohol. This bonding is stronger, so this bond is weak. If I take water molecules again, the hydrogen bonding here is strong. This is stronger, this is stronger. அப்ப என்ன ஆகும்? இது ரெண்டுமே they don't prefer to form a bonding. So what happened? They go away from each other. So you remember other examples also. Examples ரொம்ப important நம்மளுக்கு. என்ன examples கொடுத்திருக்காங்க? Ethanol, water, carbon disulfide, acetone, carbon tetrachloride, benzene, C6H5CH3 நம்ம toluene, ethanol, cyclohexene and so on. Negative deviation என்ன ஆகும்? The force of attraction between AA molecules is much, AB molecules is force of attraction is more than AA or BB. So என்ன ஆகும்? They come very close to each other. When they come very close, delta V mixture என்ன ஆகும்? ரொம்ப கம்மியாகும். It will become a negative value. அப்படியே it will be an exothermic process. Heat will be given out. So P total will become less than the sum of all this. Examples வந்து chloroform, acetone நமக்கு textbookலயும் கொடுத்திருக்காங்க. You find a hydrogen bonding between them. So let me put Cl like this only. Why did I put that? You find a hydrogen bonding, a new hydrogen bonding between chloroform and acetone. இது என்னமா இது acetone தான் சொல்லுவாங்க. The nail polish remover. IUPAC name வந்து propanone. Common name வந்து acetone. இது வந்து chloroform. So you find a new hydrogen bonding. New hydrogen bonding என்ன ஆகும்? The molecules come very close. Between chloroform molecules நம்மளுக்கு first hydrogen bonding இல்ல, அப்படியே acetone molecules நடுவுலனும் there is no hydrogen bonding. This bonding, new bonding makes it so stronger that molecules வந்து ரொம்ப closer வந்துடும். So negative deviation P total will be less than the sum of PA plus PP. Positive deviation it will be greater value. So நம்ம பார்த்த first graph வந்து ideal solution இங்க dotted கொடுத்திருக்காங்க. Positive deviation curves எல்லாம் மேல வரும், negative deviation curves வந்து கீழ வரும். பார்த்துக்கோங்க clear. If it is a positive deviation, நம்மளுக்கு என்னது P total வந்து ஜாஸ்தியா இருக்கு. So it will go up. P total வந்து கீழ வந்தா it will be a negative deviation. Positive deviation என்ன இருக்கும்? Delta H mixture is greater than 0. Greater than 0 னா நம்ம endothermic. இது வந்து positive. இங்க வந்து negative. இதுவும் negative. Negative என்ன exothermic. புரியுதா மைத்திரி அதித்தி? It's clear. Right? ரொம்ப easy. அந்த no confusion at all. A very basic thing. Non-ideal solutions form azeotrope. Azeotrope என்ன நம்ம mixture என்ன பார்த்திருக்கோம்? One was ethyl alcohol and water. என்னமா positive deviation from Raoult's law. இன்னொன்று வந்து let me say we have taken chloroform, acetone இருக்கு. இல்லைன்னா we will have nitric acid and water also. இது negative deviation. If I take a mixtureல பார்த்தா ethyl alcoholக்கு ஒரு boiling point இருக்கும், waterக்கு ஒரு boiling point இருக்கும். கரெக்டா இல்லையா? If you are taking two liquids, ரெண்டு liquids two different boiling points இருக்கும். After some composition என்ன ஆகும்? ரெண்டுமே ஒரே boiling pointல இருக்கும். And both will boil at same temperature. When both the liquids boil at the same temperature, அதுக்கு வந்து நம்ம சொல்றது azeotrope. புரியுறதாமா? ethyl alcoholக்கு ஒரு boiling point இருக்கும், waterக்கு ஒரு boiling point இருக்கும். ஒரு compositionல there will be some composition, generally 95% water and 5% alcohol. இல்லைன்னா 90% water 10% alcohol வரும்போது என்ன ஆகும்னா they both will boil at one particular temperature. Such a mixture வந்து we will call it as an azeotrope, which will boil at a specific composition known as azeotropic composition. They will have a constant boiling point. That is, they both will boil at one particular temperature. Azeotropes வந்து two types இருக்கு நம்மளுக்கு. And azeotrope இருக்கும்போது we cannot separate by fractional distillation. Fractional distillation எப்போ யூஸ் பண்ணுவோம்? When normal distillation boiling points வந்து ரொம்ப டிஃபரன்ஸா இருந்தா, if the boiling point of two liquids வந்து ரொம்ப ஜாஸ்தியா இருந்தா, when more than 25 or more than 30 degrees difference இருந்தா we will use normal distillation. இல்ல difference in the boiling point வந்து 25 and below இருந்தா நம்ம என்ன யூஸ் பண்ணுவோம்? Fractional distillation. In the constant boiling mixture வந்து we cannot separate it by fractional distillation. In the constant boiling mixtures வந்து நமக்கு two different types இருக்கும். Minimum boiling azeotrope, maximum boiling azeotrope. இது பத்தி பார்க்கலாம். Minimum boiling azeotrope and maximum boiling azeotrope. Azeotrope என்னன்னு புரிஞ்சுதாம்மா ரெண்டு பேருக்கும்? Azeotrope it's a constant boiling mixture. ஒரு compositionல when at certain composition, if the liquid mixture boils at one particular temperature, we call it as a constant boiling mixture. அது வந்து நம்ம azeotrope சொல்லுவோம். Ethanol water mixture வந்து I said no 95% by volume of ethanol, and if it has 5% water, they will have one constant boiling point. எதனால minimum boiling azeotrope ன்னு சொல்றோம்? When does the liquid boil? When vapor pressure is equal to atmospheric pressure, right? எப்போ boil ஆகுமா liquid? When the vapor pressure is equal to atmospheric pressure. இப்ப liquids வந்து force of attraction கம்மியா இருந்தா என்ன ஆகும்? They go into the vapor state easily. If they go into the vapor state easily, they will be equal to the atmospheric pressure and easier boil out. So they will boil at a lower temperature. So those which show positive deviation, those which show positive deviation will form a minimum boiling azeotrope. ஏதாவது doubt இருக்கா? When the force of attraction between the molecules வந்து ஜாஸ்தியா இருந்தா என்ன ஆகும்? They don't go into the vapor state. அப்ப என்ன பண்ணணும்? We have to heat it to a higher temperature. So they form a maximum boiling azeotrope. You remember this, nitric acid and water, நம்ம textbookல இருக்கு. So whatever you have in the textbook, you will have to remember certain composition. 68% nitric acid and 32% water. 393.5 is, what is the boiling point of water? 373 Kelvin, 100 degrees Celsius. So it is boiling at a temperature higher than 373 Kelvin. So a mixture of 68% nitric acid and 32% water will boil at a temperature more than that of water and the nitric acid. Ma purinjida? I think no doubts. So we are taking up a graph of temperature versus composition. இது என்ன? azeotrope ஓட graphs. Vertical axis என்ன இதம்மா? So if you see, this is the azeotropic composition where you have only liquids. If you go, this is generally used to separate it. We will have a separation that we will do. You can see there's one line which shows for a vapor, a line which is shown down is for a liquid. This is the vapor line. Okay, let me take a different color. இது நம்மளுக்கு vapor state, இது liquid state. In between whatever we are getting will be both a mixture of a liquid and a vapor. Composition கொடுத்திருக்காங்க. இங்க இப்ப two components, one solute, one solid. The same thing that we have drawn in ideal solution, same we are drawing it. X mole fraction of solute ஆயிருத்தா, Y a solvent. Here is shown as 0%. So இது நம்மளுக்கு Y ஓட graph, இது X ஓட graph. This is X 100%, Y 0%. So if I want a pure Y or a pure A, என்ன பண்ணணும்னா, if I want pure Y, I'll take this composition and start distilling out. இங்க போனா we will get pure X. If you take only this liquid composition, if you go with என்ன சொல்வாங்க, distillation பண்ணா நமக்கு pure X வரும். In the part of the liquid, whatever we are getting or a vapor, pure Y, நம்ம distill பண்ணா we'll have more of the residue left of Y. இது எதுக்கு பண்றோம், நம்ம ஒரு type of mixture. இது என்ன mixture அம்மா? Low, or not low, we'll take minimum boiling azeotrope. Just give a reading. They don't go to such complication in this. Till now they have not asked about the azeotropes. Mixture you just remember the mixture. This is the graph of minimum boiling azeotrope. Only textbook la namakku idu mattum irukuma. You remember this composition, that's more important. Just give a reading about this. There's no paper so far asking about this part, about the azeotropes. This is the maximum boiling azeotrope. இங்க என்ன கொடுத்திருக்காங்க பாக்குறீங்களா? It's a mixture of liquid and vapor. நம்ம இது separate பண்ணா we get a pure Y this side, whatever you are trying to do. I mean, if you take this mixture at this part, and you cannot separate this part by fractional distillation. You can either take this part or this part and you can separate it by fractional distillation. ஏதாவது doubt இருக்கா? Or is it when my system is hanging? இல்ல ஒண்ணுமே சொல்ல Aditi and Maitri, you are not speaking anything? Vimla? Vimla? Fine. The boiling point of an azeotropic mixture of water and ethanol is less than that of water and ethanol. The mixture shows any deviation. Fine. You don't get problems on azeotropic mixtures at all. I think azeotropic mixtures patti we don't have anything for the NEET exam nor the board exam. அது வந்து ஐஐடில ஐஐடி மெயின்ஸ்லயும் இருக்குது, ஐஐடி அட்வான்ஸ்ல இருக்கு. I just speak to sir. We don't have any questions on that so far. Yes, I do understand the graphs. It's okay. Take it light. If you have any doubts, you can ask me tomorrow. But you will have to remember the azeotropic mixture. நீங்க ஏதாவது என்சிஆர்டி டெக்ஸ்ட் புக்ல இருக்கும். ஒன் வந்து இத்தால் ஆல்கோஹால் அண்ட் வாட்டர், இந்த ரெண்டு எக்ஸாம்பிள்ஸ் மட்டும் தான் இருக்கு. இத்தால் ஆல்கோஹால் அண்ட் வாட்டர், இன்னொன்று வந்து நைட்ரிக் ஆசிட் and water. You remember only these two. That will be enough. Graphs of the first one, positive and negative deviation. First graphs paathirukkalla Raoult's law, which shows Raoult's law, ideal solution, non-ideal solution. And the moon graphs important namalku. In the graphs purinjida. These are important for us. These three graphs. First graph, okay. In the graph, adukapram positive and negative deviation. Azeotropes, parvala, you don't need to bother about it. Idu mattu parangamma, azeotropic mixture patti. Okay, Aditi? Fine. Look at this illustration and then tell me the boiling point of an azeotropic mixture of water and ethanol is less than that of water and ethanol. The mixture shows positive or negative deviation. Ethanol water positive deviation காட்டுறோமா இல்லனா negative deviation? Ethanol and water வந்து positive deviation from Raoult's law. Which of the following does not show positive deviation? Fine. Which of the following does not show positive deviation? Chloroform and acetone வந்து நம்மளுக்கு என்ன காட்டும்? Negative deviation from Raoult's law. எதனால the negative deviation? Why is it showing negative deviation? Because of the new hydrogen bonding. I'll do one thing. I'll just get a book and then explain you about any questions asked also. I'll see if I can give you. Okay. Fine. Let me take up this one. This is a curve for I take ethyl alcohol and water. If I take a mixture of ethyl alcohol and water. In the composition, என்ன composition இருக்கும்? Exact composition வந்து 95. What is it they are saying less than, ma'am? புரியல Aditys. 95.4%. இது வந்து 4.6%, 95.4% alcohol, 4.6% water. Exact composition எடுத்தா. ஐதி நீ சொல்றது எனக்கு ஒண்ணுமே புரியல. What is that? Just hold on for a minute. I'll take some other book and then explain you if there are any questions, because I don't find any questions on that. Ethanol and water question la enna doubt irukku? Amma adan na sonna boiling point of azeotropic mixture of water and ethanol will be less than the boiling point of water and ethanol. When water and ethanol நடுவுல நம்மளுக்கு hydrogen bonding வந்து கம்மியா இருக்குமோ, water will also go into the vapor state, ethanol will also go into the vapor state easily. ரெண்டுமே vapor stateல ஜாஸ்தியா இருந்தா என்ன ஆகும்? It will reach the atmospheric pressure very easily. அப்ப boiling point என்ன ஆகும்? கம்மியா இருக்கும். The azeotropic mixture எதுக்கு ஜாஸ்தியான்னு சொல்லிருக்கேன்? நம்மளுக்கு 370sல this is for water and nitric acid mixture. Ethanol and water boiling point வந்து நமக்கு it will be less than 373 Kelvin. You answered option A for the next one. I thought you answered for next one. I said this only, positive deviation. Because I got your answers here, I thought it was for the next question. Because we have seen the example, Ilya. Water and ethyl alcohol example, என்ன example அதற்கு? It's a positive deviation, இல்ல? Ethyl alcohol and water வந்து positive deviation தான் நம்மளுக்கு. So whenever a mixture shows a positive deviation, இது வந்து நம்மளுக்கு minimum boiling azeotrope ஆகும். Minimum boiling azeotrope பண்ண the boiling point of it will be less than that of ethanol or water. Other negative deviation chloro இது கொடுத்திருக்காங்க. Generally we have this in the textbook. So இது வந்து negative deviation mixture. இதோட what will it form? It will form a maximum boiling azeotrope. Maximum boiling azeotrope பண்ண the boiling point of the mixture will be more than that of water or the nitric acid. Okay? And Aditi, I know both of you answered A. I thought it is for the next question. So this shows a negative deviation. It forms maximum boiling azeotrope. Is it okay? You understood why it is forming a maximum boiling azeotrope or minimum, Aditi? Purinjida? And what about you, Aditi? Sorry, mic clear. It's okay, Aditi, whatever you have answered, did you understand now? Okay, fine. Because by the time I got your answer, now only in the question poitan. So I thought you were answering this question because it was direct question. I thought both of you were answering this. Sir, இது புரிஞ்சுதா உங்க ரெண்டு பேருக்கு? Did you understand this? I'll tell you about these graphs in case if I find any paper on this topic, I'll just explain you on this. Okay, phase diagrams நம்மளுக்கு important கிடையாது. You get this in IIT Advanced. In case if any of the AIMS paper, old AIMS paper in the topic பத்தி இருந்தா I'll just explain you. Okay? வேற ஏதாவது doubt இருக்கா? And what about the graphs of ideal and non-ideal solutions? இந்த graphs புரிஞ்சுதாம்மா? So shall we end? Or இன்னும் இருக்கா? இன்னும் slide ஏதாவது இருக்கா? So we have seen, இது வந்து ரொம்ப important நம்மளுக்கு. Solid liquid solution, we will study about lowering of vapor pressure, elevation and boiling point. Okay, before this we will study about a different way of Raoult's law. Whatever we defined initially வந்து நம்ம ரெண்டு liquids எடுத்து பார்த்திருக்கோம். இப்போ வந்து solid and liquid. எது பத்தி டவுட் இருக்குமா உனக்கு? Azeotropic mixture தானே? Okay, let me take this way. A molecules and B molecules இருக்கு. If the force of attraction வந்து A and B நடுவுல ரொம்ப கம்மியா இருந்தா என்ன ஆகும்? A goes up into the vapor state, B also goes into the vapor state easily. So அப்ப என்ன ஆகும்? Vapor pressure will become equal to atmospheric pressure. If vapor pressure is becoming equal to atmospheric pressure, the liquid starts boiling. Liquid boils at a lower temperature. அப்படி இல்லாம A and B நடுவுல attractions வந்து ரொம்ப ஜாஸ்தியா இருந்தா they don't prefer to go into the vapor state. So if they don't prefer to go into the vapor state, நம்ம என்ன பண்ணணும், ரொம்ப ஜாஸ்தியா ஹீட் பண்ணணும், boil if it has to boil. So attractions வந்து ஜாஸ்தியா இருந்தா, if AB attractions are more than AA or BB, we need to heat it to a higher temperature. So in the mixture வந்து it will form maximum boiling azeotrope. Azeotrope பண்ணா என்ன? Once we start heating, some amount of A is going away, some amount of B is going. There will be some part of A and B left. If let me take, I am taking A with a boiling point of 373 Kelvin and B with a boiling point of 353 Kelvin. Once we reach this boiling point of 353 Kelvin, ennaagum B complete evaporate aayidum. We will have very less of B. Once we reach around 373, A starts going away. But some amount of B and A ennaagum rendume ore boiling point la irukum. If it is having more attraction than that of A or BB, constant boiling mixture வந்து the boiling point will be more than this. If it is less than that of attractive forces வந்து கம்மியா இருந்தா இந்த boiling point வந்து என்ன ஆகும், ரொம்ப கம்மியா இருக்கும். ஏன்னா they easily go to vapor state. புரிஞ்சுதா ஐத்தி? Again a solid and a liquid கொடுத்திருக்காங்க. நம்ம we will see this part of it in the next class. Okay? Okay ma, bye. Thank you. Bye ma, good night.